Alex, have you ever thought how difficult it must be to build a wind park at sea?
Actually, I spend a lot of time thinking about this. I'm sitting on the board of a Swedish wind tech company called Modvion that produces wind power towers out of wood. So we spend a lot of time thinking about, how can we roll out, cut cost, and, make wind energy more available for everyone.
You just mentioned challenges there, but challenges are there to be tackled, and the world needs more renewable energy, and we need it fast. Wind is a way forward.
It sure is. And today we're going to talk to the CEO of a very innovative company, Aikido, that creates submersible, foldable, floating wind platforms to increase the speed of deployment and reduce cost. Now, Christina, can you repeat that very fast?
No, it's a mouthful, but we will actually find out what it means. So welcome to this episode of The Switch to a Green Economy. My name is Kristina Hagström-Milewska.
And I'm Alexander Helling, and stay with us for a fascinating conversation.
Joining us today is a very special guest. He is the CEO of Aikido, a company that produces a foldable kind of floating wind platform that can be deployed faster and cheaper than ordinary offshore wind platforms. A warm welcome to you, Sam Kenner.
Thank you, Christina, and thank you, Alex, for having me.
I'm so looking forward to this conversation, Sam, but can we just start with the name? I used to practice Aikido when I was a kid. And where does the name come from? Does it have something to do with the actual sport, or, what's the connection?
So the origin of the name is that it was the really bad acronym of our project under an incubator that we spun out of called Other Lab. And I forget the acronym, but it was something like aerodynamic, inertial, kinetic, intelligent, discovery, something optimization. And then when we were deciding on a company name, of course, Aikido, using that project name was top of the list. And then I did just some very limited Wikipedia research on Aikido and the three Japanese characters, I, Ki, and Do, which roughly translate, I'm going to get this wrong, so apologize to everyone out there, as harnessing your opponent's energy for your own gain. We thought that was very fitting for offshore wind.
Very fitting.
Yeah.
Very fitting. I saw in front of me that it was something like Aikido, because that's how the hands and the feet are going around when you're competing. But this was much more clever.
Yeah, and it's a lot about also folding people, right?
Yeah, exactly.
We had a bunch of theories, but I think that you actually explained it very well to us. On that topic, I actually wanted us to move forward in this, because it's easy to just jump over and start talking about technology and wind. And this is where you guys could probably stay for long. But I want you now, Sam Kenner, to explain to me, as you would to a 10-year-old, give me the benefits and the crash course of wind as an energy source.
Okay. Can I give it to you as a 5-year-old? Because I have a 5-year-old son.
It's okay. Even better.
Okay, so there are 3 different types of wind energy in general. One is onshore wind, building wind turbines on land. The next is fixed bottom offshore wind, building wind turbines in shallow water where they are directly down on the seabed. And the third is floating wind, which is building wind turbines on floating platforms in deeper water. We've been building onshore wind since the 70s. The Danes, right, of course, are great pioneers in that field. We started building the first offshore wind in the early 90s. And then when it really hit gangbusters in Europe, especially in the 2000s and the 2010s. And in 2009, actually, the first floating wind turbine was built off the coast of Norway by Statoil, which is now Equinor. So there are some distinct, I'd say, advantages and drawbacks to each of these types of wind.
Which we will come back to. But can you just give me also if you compare wind to other renewables, what would be your top 3 things why we need to focus on it?
Okay, well, number one, I would say, right, is the capacity factor of wind. And so depending on onshore wind or offshore wind, right, we're now seeing capacity factors in excess of 50%, right? So the capacity factor is how often the unit, whether it's a solar panel or a turbine, is producing at its nameplate capacity, right? And so solar is generally something like in the 30s, because it's day and it's night and there's dust and there's clouds and something like that. And so wind, in terms of, right, the energy that's actually produced, not the power rating of the actual unit, wind is really good at producing energy a lot of the time. I would say another great thing about offshore wind, and specifically floating offshore wind, right, is its flexibility in siting and getting it away from people. It turns out people don't like energy projects around. And
not in their backyard.
Not in their backyard or their front yard or their neighbor's backyard. And so the other great benefit of particularly offshore wind, right, is getting it further away where people don't have to see it and therefore don't raise a stink about it. And the third one I would say is, again, this is offshore wind and areas of floating offshore winds, is its co-location next to load centers. I think a lot of the challenges that you see, again, trying with these siting concerns, is that you end up here in the U.S. putting all of this onshore wind in the Midwest or North Texas, and we're having huge, right, transmission challenges with our grid. There's certainly transmission challenges putting these things offshore and bringing the power back to shore. But once the cables land on shore, you're generally going to be pretty close to load centers, because it's like the UN, right, has a statistic that like 2/3 of the world's population lives within, 100 miles of the coast, right? So I would say those three advantages for wind, and specifically offshore wind.
So I would give you a green button here, the green one and the red one here. So you would get an awesome from me. Let's see what Alex says about that one. Did he explain it in a good way?
Yeah, yes, definitely. And I have a ton of follow-up questions. A couple of them may be a little bit technical, but just, Sam, it is interesting to see what are the difference in the capacity factor if you go onshore or offshore. Is it a big difference, or what's the how much extra do you actually gain from doing it offshore?
Yeah, I would say that in general, I think onshore wind sees capacity factors in the 40s, and that offshore wind in general sees capacity factors in the low 50s. And a lot of that is also due to the other main benefit of offshore wind, is that it's very windy in lots of places on the ocean. And so average wind speeds are very high. And this also, right, helps the capacity factors as well.
Yeah, and then the second question, because it's always, when we look into this from Modion perspective, it comes down to the cost, right? How do you does that capacity factor allow you to build these wind platforms, and what do you see? How did you come about the idea for Aikido, and how do you work to actually reduce the cost?
Yeah, great question. So I and one of my co-founders, Bingbin Yu, we worked at a company called Principal Power for about 6 years together. And at Principal Power, we deployed some of the first floating wind turbines in the world. They're now operating off of Portugal, called the Windfloat Atlantic project, and off of Scotland, called the Kincardine project. And so we got to see really firsthand, being in the technical weeds on these projects, around the challenges and also the opportunities facing the industry. And with that, something that became crystal clear is that we can build, say, 3 or 5 of these units using conventional technology, but it's really hard to imagine what it would take in terms of the construction and the port space and the areas to build a commercial scale floating wind farm, which can have something like 50 or 100 units, right? Because commercial scale renewable energy projects are now, a gigawatt or above. And each unit now is roughly around 15 megawatts of capacity for the turbines. And so that equates to roughly 50 or 100 units. And each of these platforms, right, is a huge structure. And in fixed bottom offshore wind, we have gotten very good at installing them, building them and installing them quickly. We can get the whole project basically constructed in 2 to 3 years and have the turbine spinning. And for floating wind, there's no commercial floating wind project that is spinning to date, but people think that that could take somewhere, between, twice as long in order to do that. And so Aikido, our technology, is designed to basically have that construction time and really try to meet these timelines that has been set forth by the fixed bottom offshore wind industry.
Yeah, because most of the you build almost a full wind turbine at port, right? And then you ship them out and wreck them. So like the IKEA style version where it's more foldable. You put them together when you get them into the port and you ship them out and then erect them, right? That's the whole concept.
That's it. That's exactly right. Yeah, the flat pack.
The flat pack.
But I know by experience it's very difficult to put those flat packs together. Is it?
It is difficult to put them together. Luckily, right, we don't put that on, unlike IKEA, we don't put that on the consumer. We are going to be the ones.
Good for us.
We are going to be the ones coordinating the assembly. In floating wind jargon, that's called final assembly, where all of these major components come together at an assembly port, and you have to essentially put all the pieces together. And using conventional technology, all of those pieces are welded together, which requires a tremendous amount of time, is weather dependent, and it requires a tremendous amount of space. And so at Aikido, we basically can perform the final assembly in 1/3 of the space, and we think in 1/2 of the time as this conventional welded technology.
That's actually an idea you could sell to IKEA, because it would work better than how I build my IKEA furniture right now. Definitely.
So Sam, another question. If you look at the potential for this, if we can get the cost down, if we can build these huge floating wind farm, what's the potential? How much can we produce?
I mean, the potential the potential is massive, right? So the estimates are that 80% of the world's sort of attainable offshore wind resource is in deeper waters, where we need floating wind platforms to access this great resource. And so most people think that offshore wind is sort of an absolute necessity for a decarbonized grid, right, around the world, whether it's in the US or Scandinavia or, Northern Europe, Southern Europe, Japan, Korea, Asia Pacific, Australia, right? This is going to be a critical component of a decarbonized grid, along with, of course, clean, firm sources like geothermal. Obviously, solar and energy storage has a big role to play, but especially wind, especially offshore wind, which can produce power, especially in the evenings. A lot of the times, the wind picks up in the evening, which is a huge critical challenge for the grid, as well as in winter months where the solar resource is generally lower. Offshore wind can pick up there, so we think that's hugely complementary to other existing renewable forms.
Actually, you are a part of the Fellows Program at Breakthrough Energy Venture, Bill Gates' Climate Innovation Fund. And they're talking very much about this ecosystem and making sure that everybody is collaborating to be able to actually help us solve the real resource. How important has it been to be funded by them, and how do you actually work to, move forward with what you just said, this collaboration and being able to build out that fast?
Yeah, the Breakthrough Energy Fellowship has been tremendously impactful for us. I cannot, overstate that. It is really critical to getting our company off the ground and starting to work on our first pilot project, which I can talk about later. And it's been a great, like you mentioned, sort of ecosystem of support from, the technical We met there one of our what's called business fellows. Her name is Jane Zhang, who brings something like 30 years of offshore experience from Shell doing their deep water projects from around the world. She connected us with other ex-Shell engineers who are also consulting with us. So to bring that technical expertise right around the table, and bring all that experience from really deploying right projects in the ocean, which is a challenge from many different ways, has been great. Right, there's also business and commercial support as well, and so all of these resources has been tremendously impactful. Of course, they provide funding for us, which is great as well. And so, yeah, this fellowship program has been hugely impactful, and we're so grateful to be a part of this program. And we are sad to be.
What has been the biggest changes and lessons you've brought with you from that into commercializing and taking it to the next step?
I would say.
Does the IKEA idea come from there? Or is it yours?
I would say it was part of a, brainstorm session of really trying to distill the value proposition, right? And what we're bringing to our customers, the offshore wind developers. And so certainly, right, we've had many, right, close sort of sessions with these business fellows that are supporting the multitude of these breakthrough energy fellowships teams. And through those discussions, really distilling down what is the value prop and how can we best communicate that to our customers.
Sam, I would really like to hear a little bit about your pilot project and the time plan for that, and when can we actually see the first project up and running?
Yeah, absolutely. So we are constructing a 1/4 scale unit currently now in Louisiana, and we will be testing it later this summer and into the fall. We will not be having an operating wind turbine on this unit, but we will be mainly focusing on sort of proving out the key features of our platform, which I mentioned to you previously, right? And this is the fast assembly in a small space, the ease of the transport and deployment. And then the other critical aspect is as you go from this flat pack configuration to then the basically upended wide operational configuration, we use an upending process, which is actually just driven by water. So we're just pumping water in and out of the ballast tanks on the platform. And that is what we're going to be proving and de-risking with this pilot project. When we show our design and our technology to customers and sort of given our experience, right, designing 10 megawatt floating wind units, once the platform is in its upright configuration, everything looks sort of more conventional. They don't see any major issues, right, with sticking a wind turbine on and putting it out to sea for 25 years. But all of the interesting, I would say, technology and the portions that we need to de-risk are around final assembly, transportation, upending, and installation, if you will. So that's what we're going to be focusing on this summer. And again, I would say that all of this project was really, we really sort of re-scoped it based on discussions with the Breakthrough Energy fellows and these business fellows, who really drilled down. I remember conversations with Jane, who I mentioned, right? It said, what are you guys trying to show with this? What do customers want to see? And that's how we ended up, with this pilot project.
Super cool.
Interesting. What's as you are like moving into this, what keeps you up at night regarding this pilot project?
Many things. Yeah, I would say, right. I mean, there's just the devil's in the details, I guess I would say. And on these, and I'm technical. I have a PhD in mechanical engineering. We have two chief engineers who are also highly technical on the platform and the turbine and control side. And so we have a small team, and all of us are getting down into the weeds very quickly on the types of connections that we're using. even just the simple thing which you would think is just pumping water in and out of ballast tanks, right, has even just become not a roadblock, but it's something that we really have to figure out. So all of these little things that you think, oh yeah, we'll just get a pump that can pump water here and pump water there. Turns out, it's not quite as simple as that. And so all of these, little details. When you're a team of 6, everyone's figuring, everything out. And so, all of those, I would say.
It must be very exciting at the same time. Actually, I had a thought. So like, when you are, one thing that would keep me up at night is like maintenance of these turbines. And I was thinking, how do you get up there? You go out with a boat and then you go out with a helicopter, or how do you travel? Do you have small elevators taking you up? How do you actually maintain those huge turbines?
It's a great question. So a lot of the solutions that you mentioned, exist. There are helipads on top of wind turbines. There certainly could be helipads on the platforms themselves. There are also boat landings. So you would bring a boat, a crew transfer vessel called a CTV, out and get people on the platforms, and then you get them inside the towers, and then you'd have to get them up. There are devices to assist the workers to get up the ladders. This is 150 meter tall towers now, as Modvion is
sounds like a job for like a Superman or something.
It's very impressive.
We'll bring you to the Modvion tower, Christina. You can climb.
I would
actually
cool. Like that adrenaline junkie as I am. I think I look forward to that. It would be nice.
So exactly, maintenance is definitely a challenge. One of the interesting things that is, I would say, an open question in floating wind is whether we perform maintenance out at sea, which is what's done in the fixed bottom industry, or whether we disconnect our mooring and cabling system and bring the unit back to the port. And therefore, when you're in the port in the sheltered area, then you can use onshore cranes and other, sort of existing infrastructure in your port. And so that strategy has actually been more employed in the very early projects, for floating wind. Equinor is currently doing this with their High Wind Scotland project. They have 5 units that they installed now, I think, 7-8 years ago, maybe, off of Scotland. They are disconnecting them and then towing them across the North Sea back to Norway.
Cool.
And putting them in, one of their deep water ports to perform maintenance.
Interesting. Oh, I didn't know that. Sam, I don't know, Christian, I have to take another technical question.
Try me. Okay.
No, but we work a lot in Japan and Taiwan, and they have a massive need of renewable energy, right? It's very difficult, or there's not that much space to do onshore wind anymore. So they're looking a lot on offshore. But of course, you have challenging wind conditions with a lot of hurricanes and things, typhoons. Does floating wind, how does that work? Can it withstand forces like that, or how does it work?
Yeah. So from a platform perspective, we say we can design for anything. There will be some inherent extra costs in terms of the design of maybe the platform or the mooring system, but I would say in general, typhoons, from the platform perspective, may not end up being sort of a driving case for us. May not be the worst case. There may be some other cases and other different wave conditions or wind conditions that can be more challenging. From the turbine perspective, for sure, that's going to be a challenge on the design of the blades and how the turbine can withstand such high wind speeds. So I think, the turbine suppliers, the Vestises and others are certainly working and on these typhoon resistant turbines. One interesting thing, that could potentially happen in the floating wind industry is that if you had a very good idea of where this typhoon track was coming and you knew, a certain number of units were in its path, you could disconnect the floating wind unit from its mooring and cabling system and get it out of the way and tow it out of the way. I'm not sure if that works on a commercial scale, No. And it's certainly, but this is what's done in oil and gas industry. When a hurricane comes into the Gulf of Mexico, you pull up your whole mooring system, all of your oil production systems, you shut everything down, you evacuate the platform, and you actually just let the platform ride out the storm. I didn't realize this. And it was talking with oil and gas guys. And then after the storm passes, they have to go with the helicopter and say, and of course they have, locators on it, but where is the platform? Where has it moved to? So I'm not saying we should necessarily
we now have wind power producing not for Taiwan, but for the Philippines.
Yeah, exactly. But these are the thing, right? The types of strategies that are employed offshore to deal with these extreme conditions.
Sounds like there are some challenges still to be solved. If you would have a magic wand and be able to solve 3 of the biggest challenges that would actually pave the way for you moving forward, what would that be?
I would say that one of the main questions that we get, right, is where is commercial scale floating wind, right? We have these small projects, 5 units, 8 units. Equinor just installed, right, 88 megawatts, Hywind Tampen project. We don't have any 500 megawatts, 1 gigawatt projects that I can point to and say, like, look, here is commercial scale floating wind. It is operating. So the first slash of my magic wand would be to put a commercial scale floating wind. And, it was likely with someone else's technology. Of course, would love to be the first technology to use commercial scale floating wind, but I'm definitely the first to say that, right? We need to follow, a technology, right? De-risking process, improving process. And so if, an incumbent technology, right? May, be used for this first floating wind projects.
And the second thing?
And the second thing I would say is really try and streamline offshore wind project development. And of course, this is a very, state or national challenge, whether it's in California or in Scotland. But these projects, right, can take anywhere from 5, 8 to 10 years to permit and develop them. And I think for offshore wind to really take off, we need to streamline that process, get it down to permitting timelines, that is common for other renewables.
Do you recognize that, Alex? From geothermal?
Exactly.
Everybody has the same wish. Let's just fix it.
Yeah. Yep. And the third slash of my wand, I would say to pour even more money into, right, R&D. I think those first points are around deployment, right? We need more deployment. We need faster deployment. We need to see it going. And I think, simultaneously, we also need innovation. And so something at Aikido that we're also looking into, right, are tweaks on the design of the wind turbine to make it more amenable to operation on a floating platform. All of the turbines that we're using are essentially land-based designs. And so from a platform design perspective, we need to make the turbine think that it's still sort of on land. It needs to roughly be, right, quite stable. And that drives up the cost and the complexity of the platform designs. And so if we're able to take a more first principles approach to the design of the turbine, we think that can dramatically slash costs for floating wind.
Interesting.
And so that's some other technology that we are working on. That's not our go-to-market strategy. But in terms of deployment, right, and innovation, we need to, take a 2-pronged approach. And so solving both of those with the magic wand would be great.
If I had a magic wand, I would also talk a little bit more about awareness. A thing I can't let go is a conversation I've had with my mother regarding offshore wind. And she sees in front of her an ocean filled with giant pinwheels everywhere. And she gets really scared about this. How do we create more awareness about the actual opportunity about this and how we collaborate, for example, with other renewables at the same time so we solve the bigger puzzle?
Okay, well, first off, tell your mother that most of these offshore wind projects are 15 to 20 miles offshore, especially the floating ones. And so
she can't see them, even with her glasses.
With her glasses, yeah. I don't want to speak to her vision. But at that distance, the visual impact is very low. And so they're not going to be in your face. The other point, right, is that there's a huge, I would say, economic opportunity for right, cities, states, or countries. And this is especially true for offshore wind when you look at it as it compared to other renewables. There is, right, a tremendous amount of construction that has to take place in your port in terms of the manufacturing of the steel components, or whether it's a concrete foundation, this final assembly process, right? All of the vessels that are required to do this, we need to upgrade our ports and our other maritime infrastructure in order to do this. And so, in the floating wind industry, especially in California, we talk about this, this really generational opportunity, to bring clean energy and economic development to, right, our coastal cities. And so I would say, although your mom may not be getting a construction job in the near future, I think who knows? I think that I hope that she can see, right, that there's a huge opportunity here to revitalize a lot of these coastal cities and ports, and play a major part in this green transition.
Yeah,
my mother will like that part.
And I was just wanting to add on, Sam, it takes away, the biggest challenge, which is access to land. Right here, you have a massive amount of open ocean where, you can locate it so long out that you don't see it, you don't disturb anyone, you can produce a massive amount of green electricity. So, I find this opportunity super exciting.
So I'm really starting to understand the picture now of IKEA style. The sustainable IKEA that I don't have to build. I don't have to worry about maintaining it, because that's also feels very good for me in this case. What about you, Alex?
Yeah, I want to go out and see a floating platform. So Sam, you have to let us know when it's up and running, and we'll come out there. I want to see it in action.
Absolutely.
I want to climb it.
Absolutely. Yeah, definitely. We are hoping to host a sort of demo day for interested parties. So as long as you are not a competitor or don't plan on starting a floating wind company, you're more than welcome to come to the Gulf Coast and see this thing in action later this year.
No plan to do that. We're focusing on geothermal and to make sure to talk to people like you who can be a part of the transition to a greener economy, which you just showed to us.
So Sam, I have a technical question. When you build these deep sea wind farms, what happens with the cables? Do you run them on the ground, or how does it work?
Yeah, that's right. So this subsea cable technology, or what we sometimes call these umbilicals, carry the power from each unit, and then that gets collected to an offshore substation. And so most of this technology is able to be borrowed from the fixed bottom offshore wind industry, where this is happening today. There's one more challenge for floating, and that is the fact that there is a dynamic cable which connects to the platform. And I'm using my hands in this manner because that's usually how they are connected to the platform, via what's known as a lazy wave. And in this way, the power is, transferred from each unit to generally a floating offshore substation, where there's then one large export cable that connects the offshore substation to the onshore substation. And these cables are generally running along on the seabed, or in some cases they are buried underneath the seabed, just a couple of meters. And that's how the power gets from the offshore wind turbines and onshore and connected to the grid.
All right. So Sam, I saw a video on your website where you show how the foldable wind turbine get packed on the ship and then delivered out. When you're going to build these large-scale wind farms in the deep sea, do you transport one at a time, or do you actually transport multiple stations at the same time?
Yeah, so the idea that we have for now is that each of these units comes off what's almost like an assembly line in our port. And the goal is really try to increase throughput. And that's the whole point of our technology, is to reduce space and cut down on time of assembly and construction. And so as each unit sort of rolls off the assembly line, they can be transported via tugboat, I think like what's shown in the video, or we have many other options in terms of a barge, what's known as a semi-submersible barge, to transport the unit to the turbine installation site. So after the unit is transported, it's then upended, and then the turbine is then integrated onto the platform after the upending process. And from there, the unit is then towed out to the offshore site. So in general, that would happen one at a time. But again, right, this type of project execution happens roughly in the fixed bottom offshore wind industry. Of course, there are different steps, right, in terms of getting the monopiles out and driving them down into the seabed. And it's a logistics challenge, right? But getting this assembly line and this whole project execution to happen in concert, right, with sort of as few vessels and as lowest cost as possible in the shortest amount of time, is something that we think our technology can really facilitate and really streamline for the offshore wind developers.
Very cool. Do you need also to tailor make the vessel so that they fit, or can you use existing fleet?
Right. So one of the big value propositions of our technology is that we can use much more existing vessels in terms of the transport of these units, whether they're these barges or smaller tugboats. This is a huge challenge in the U.S., where we have a law known as the Jones Act, which further restricts the types of vessels that we can use for these activities. But in general, at Aikido, we are trying to be able to sort of give the most amount of options in terms of port space, vessels, right, construction techniques, supply chain. So to really ease a lot of the headaches of our customers who are building these projects.
I will ask you to grade your industry on a scale of 1 to 10. How ready are you for us to have it as a source of energy that is going to be of our everyday life? Where are you today?
As an industry, I think we are ready. I think the technology is proven. I would give us a 9 out of 10.
You're close, actually.
Yeah, as an industry, I think we are ready. I think the main challenge is cost. We are still, as an industry, roughly twice the cost of fixed bottom offshore wind, and we need to bring that cost down. Of course, one way to do that is to build these large projects where you can take advantage of economies of scale. But we also need innovation, and that's where Aikido comes in.
Good final words there, Sam. I have so much new information, Alex. What will you remember most from this conversation today?
The opportunity. I think that the opportunity is massive. And as Sam said, if we can get that cost down, we will be able to produce a large amount of renewable energy. So I think that one is... I will take that one with me. And the second one, as I said before, I want to go and visit one. And, preferably that you have the helicopter pad on top of the turbine. That would be the optimal.
I want a bungee jump for one. That's how my head spins. Sam, what about you? What did you bring with you from this conversation? Is there anything that you will do more or less or differently after having this conversation with us?
I think you guys definitely pushed me to make the case for why we need offshore wind in our renewable electricity generation mix. And I think that's something that, because I'm so in the offshore wind world already, I don't have to step back frequently and say, why offshore wind, right? And so it was really interesting to speak to you guys on that.
Happy to have the conversation. Definitely. I bring with me that, again, I think that you phrase it well, Alex. This is an opportunity. I see also a lot of collaboration that could be done with other renewables that can actually give us those last pieces to the puzzle we need to lay in order to solve our way forward to a greener economy and a better world, I would say. With that said, thank you very much, Sam Kenner, for joining us today. And thanks to all of you who have been listening or watching. Remember that the only and the best way to spread this is to talk about it, to share what we just heard, to tell someone else that can tell someone else and that can tell someone else, because that's how we make a difference. Your contribution, your like, and your comment is going to help us be better. So with that said, it is time to move over to say goodbye from today. Let's see if you get it this time, Alex. I think it's the 7th time we tried this, and I usually say my goodbye phrase and so on, and then you finish it. But before that, Sam, thank you very much for joining us here today.
Thank you for having me. It's been a pleasure.
And Alex, to all of you out there, take care of yourselves and
have fun. No, and someone else.
If you can, someone else. Take care, everybody, and see you around.